Hi, I'm Andy Daniel, Consulting Architect with PernixData, and I'm here to talk to you more about PernixData FVP for use with databases. So let's first talk about database workloads. To do that, let's talk a little bit about OLTP databases as an example. Right? So what does that actually look like when we're reading and writing data? So to the actual storage layer, what that actually looks like is something like this with peaks and valleys, right? Because as transactions are committed, we're actually bursting this write data down to the actual storage layer. So what we typically have to do in this case is we actually size our storage for these actual peaks, and that can be very expensive. Not only that, it actually can negate the possibility of virtualizing these systems as well. So let's think about now the fact that if we could eliminate this and actually virtualize at the same time, what that would look like. As we actually combine, for example, in a virtualized infrastructure, our databases, this actually adds to the bursty effect and causes something known as I/O blender. Now in this case, to use FVP, we're actually going to provision VMware ESXi, right? And then these are going to connect down to our actual storage. Now, when we actually size the storage, remember, we're sizing for these peaks. So let's add in FVP software in this case, and that's actually going to be added in at the host layer. And this is going to be our performance tier now. So rather than actually sizing now our storage to handle these peaks, we're actually going to do that at this level here with FVP. Right? So what do we use to do that? Right? We're actually going to use host side RAM and flash. By utilizing these resources, we don't have to actually see the latency of this storage. And to demonstrate that, let's talk a little bit about the I/O flow. Traditionally, what's going to happen when this database server actually writes down, it's going to write all the way to the storage, and then the storage is going to acknowledge that, and that's actually seen as our latency, right? All the way down and back. But now with FVP actually in play, what we're going to do is we're actually going to accelerate, and we're going to intercept this I/O right here in the flash or in the RAM layer, right? So that write comes in. We're now going to replicate it, right? And then we're going to immediately acknowledge it back to the host. So now latency is actually at the latency of the server side resources rather than having to travel the storage fabric all the way down to the storage and back. So what this means now is that this latency is now ultra low, right? Ultra low latency here rather than the latency of the actual storage array. And so not only have we cut this latency by orders of magnitude, but we're also now no longer sizing our storage backend for these actual peaks. We can actually size it for more steady state. And not only that, we can actually size it primarily for capacity and data services. Because again, we're going to handle performance now actually at the FVP layer here, actually in the host. So that is databases with FVP. For more, check us out on the web at PernixData.com.